Good evening, Northern Colorado. This is Whiskey Zero Delta Delta Zulu. My name is Dave, and I'll be your net control for tonight's Northern Colorado Amateur Radio Club TechNet. I don't know if Steve's not with us tonight, so I was actually not supposed to be net control tonight, so I do not have a topic prepared. So we will do an open topic. Let's start with some check-ins. Anybody who'd like to check in to tonight's net, please give a call.
Good evening, Dave, and Zero EMP Mobile. Greg, normally in Fort Collins, heading home from Longmont.
This is AE0BQ Alpha Echo 0 Bravo, Quebec. Daryl in Longmont.
Kilo Alpha 6, Echo Tango Echo, Jim in Loveland.
This is Kilo Echo 0 Lima Charlie Kilo, KE0LCK, the other Mike from Windsor.
November 0, Whiskey, India, Quebec, Carrie in Loveland.
Alpha Echo 0, Charlie Foxtrot, Ben, Fort Collins.
Good evening to N0 EMP Greg, AE0BQ Daryl, KA6ETE Jim, KE0LCK Mike, N0WIQ Carrie, AE0CF Ben. Any other check-ins for tonight's Northern Colorado Amateur Radio Club TechNet? Please call.
This is Kilo Uniform, W7KRU. Rick, up in Rake.
Whiskey 0 Alpha Sierra Papa, W0ASP. Terry in Berthoud.
Good evening, W7KRU, Rick, and W0ASP, Terry. Any other check-ins, please call.
Charlie 0, Zulu India Echo. Darren, be on for about 20 minutes.
Good evening to Darren, KC0ZIE. Any other check-ins for tonight's Northern Colorado Amateur Radio Club TechNet? Please call.
I have a suggestion for the net. This is N0WIQ.
Go ahead, Carrie.
Would suggest the subject matter of AP.
I'm sorry, what was that, Carrie?
Said EMP. EMP. That's a magnetic charge that is coming from a lot of places.
So, if you want to put something in about that, I am not the scheduled net control. I am just kind of taken over, so I don't have anything prepared for that. But if you'd like to say something on that, go ahead.
I think the most notorious one is the EMP that is released by an atomic blast. But anyway, EMP comes from a lot of places. So anyway, EMP is something that happens quite a bit. And it used to be in old-fashioned cars also, because some of the pieces would come loose and take it down and make an EMP by the metal that's being their loose pieces will jam together and make an EMP. And also, that's what goes on with computer noise that can go into the radio also. So that's just basically what I was going to say, is there is some EMPs happen with regularity. Like when I was a kid, I put a CB radio in my car. It was fine as long as the car was parked and stopped. But when I started the engine, woo, all the noise. It came from the ignition system. So I had to go put some resistive spark plug wires in place to quiet it down. And EMPs is coming from computers also. So that's why you often have computer noise in your radio. So I just thought I'd mention that to you. And that's about the major thing to think about with EMPs. So back to net.
Thanks for that, Carrie. Electrical noise is definitely an issue that we deal with a lot as radio operators. I know that I definitely have seen the difference in various equipment that creates electrical noise. Anybody want to add anything about electrical noise or like RF interference and noise coming from electrical circuits that causes interference? Please call.
November Whiskey Zero Uniform.
November Whiskey Zero Uniform. What was the name?
In Fort Collins. Didn't check in, but I have some comments to make.
Yeah, please go ahead.
I think what the previous operator was referring to was generally known as EMI, electromagnetic interference. EMI, electromagnetic pulse, is what you get off of nuclear weapon detonations. Commercial equipment and almost anything certified by the FCC has to meet radiation standards so that they don't transmit more noise than is allowed by law. Normally they're tested on ranges. I've done a little bit of that myself.
Yes, and there's a lot of stuff out there that definitely causes us as hams some problems when it comes to electromagnetic interference, for sure. Anybody else want to add to that topic? Please call.
WIQ with a little more.
Go ahead, Carrie.
A lot of things in the past, especially DC motors, used to use a rotating switch for the magnetic field inside the motors. And it also made electrical noise that you could hear. And they used to use that sort of thing in early computers, too, for the fans. But on the other hand, they have gone to brushless fans, which is meaning they use the multi-phase motor to turn the fan and all that kind of stuff. But on the other hand, if you have a appropriate frequency, it will interfere with the radio too.
Yep, brushed motors are definitely a source for sure. Anybody else want to add anything on electromagnetic interference? Please call.
Zero ASP.
Go ahead, Terry.
Working with a particular interesting source of interference that maybe most people don't know about. And this is on the lower VHF bands, 6 meters, 50 megahertz and higher. I've been looking up into the 60, 70 megahertz for doing radio astronomy and meteor detection. But there are a lot of very narrow frequency tones that are across that entire band. And these are due to leakage from wired Ethernet cables. In particular, unshielded Cat5 cables radiate enough electromagnetic energy to cause an issue. So you set up a software-defined receiver on a decent antenna near your house, you're going to find a whole bunch of stuff that is actually radiating from your house, from your neighbor's Ethernet connection, from your Ethernet connection.
That's interesting. How far away would you say that you are detecting that leakage, or is that like inside of the building that you're working on, or are you detecting neighbors and whatnot?
I think some of it has to do with the gain and directivity of your antenna, but the antenna I've been playing with is a Channel Master, a TV antenna that has, it's a log periodic, and perhaps it has about an 8 dBi gain in the forward direction. Several hundred feet, you can detect these signals.
Yeah, that's interesting. You wouldn't think that the power that's being sent through an Ethernet cable is that much, but I wonder if there's anybody who's tried to see if they could decode any of the information going through an Ethernet cable with that method. Have you heard anything about that?
Well, that's the kind of thing that gets governments apoplectic, so I'm not going to go there. W0ASP.
Definitely an interesting topic for sure. This is Whiskey Zero Delta Delta Zulu, net control for the Northern Colorado Amateur Radio Club TechNet. Anybody else want to add to the topic of electromagnetic interference? Please call.
Case in point from WIQ.
Okay, there was actually somebody that doubled with you. Who was the doubling station?
NW0U.
Let's start with NW0U and we'll come to N0WIQ. Go ahead.
Yeah, just a note about Ethernet radiation is the technique and idea of intercepting spurious radiation from various sources is a very old intelligence gathering mechanism. The IBM Selectric typewriter with the ball head was a particular offender because it had a peculiar code for every letter, and so radio intercept could record the sounds of the ball being oriented, and that could then be turned into whatever was being typed. And so things like classified material had to be typed in places that would not allow that radiation to get outside.
Yeah, I definitely find that stuff interesting. Before, like, the channel hopping garage door, or not channel hopping, the rolling code garage door openers, there was that one, like, kids device that could have the firmware changed, and that thing would open, like, almost every single garage door in a matter of, like, a second or something. It's insane what technology can do these days. Anybody else want to I'm sorry, Carrie, N0WIQ, go ahead.
Through the years, I started out with Cat5 cable putting a network together. And I finally put enough Raspberry Pis together to put on my network. And all of a sudden I noticed that I couldn't use my network attached printer. So I knew there was some interference going on in that. So I've now gone to Cat7 cable, which is double shielded Cat cable. And things are working again. But before I had the Raspberry Pis all laid out open and everything else. So I put metal cases on the Raspberry Pis, and then I put in the Cat7 cable, and away we go. My network works again. I can use the network attached printer and all the other things that are on my network. Of course, my network is more extensive than most people think about because I got 16 nodes plus 24 nodes for my network, so that's just what I was going to mention about was had to go to a double shielded network cable and shields around the Raspberry Pis to make everything work right. And network right, that is.
U0ASP with a follow-up question.
Yeah, go ahead, Terry.
Carrie, I think the Cat7 cable, and correct me if I'm wrong, does that have a shield around each pair of the 4 pairs that are in the cable? And do you have any experience with the other kinds of shielded cable, like Cat5 shielded and Cat6 shielded? And I think those other cables only have a shield over the entire group of cables. Do you have any experience and insight on that? W0ASP?
want to hear about it. Cat 4 started out with 4 twisted pairs, and there was no shield around anything. Cat 5 put a spline down the center of the cable so that the twisted pairs would always be separated the same amount, and that made Cat 6 work a little bit faster because they wouldn't interfere with each other so much. Shielded Cat 6 came along and just put a shield around the whole net cable, and then put a connector on that had shield on, so it could match the shielding. Cat 7 is what they call double shielded, so I presume that each twisted pair has a shield, and there's a shield around the whole mess. So that's my view anyway. So that's my comment.
Okay, yeah, Carrie, thanks. Yeah, understood. I've also heard of situations where, in an Ethernet cable, you got the twisted pair, and the signals going down each twisted pair, you've got like green and white, and so that's a particular twisted pair. That's supposed to have a differential signal. I've heard of people mistaking connectors or miswiring the connectors so that you would use one wire of a twisted pair for the positive, say, and the other wire of a different twisted pair for a negative, and that would really increase the radiation of the cable.
So in order to properly wire an Ethernet cable for networks, there is what's called a token loop. So there's 2 standards for it. I don't know what the standard number is, but there's A and B to it, and it's white, orange, orange, white, green, blue, green, white, brown, brown. And what you do with the orange and the green is called a token loop. And a good network or a cable tester will detect an error in wiring the token loop.
Zero CF, comment?
Yeah, go ahead, Ben.
First thing is that I'm pretty sure if you miswire the Ethernet, you cause so much noise generating from outside sources that you would cause too much noise so that the actual networking part of the cable will stop working. At gigabit speeds, it just won't work anymore if you miswire it. I think at like 10 megabit, you might get a couple bits to go through, but it's generally too noisy to send bits down the wire. And it just seems like it's going to be a dead link. The other question directly related to noise and ham radio is, has anyone checked whether or not the noise emanating from these Ethernet cables is common mode or they're differential? Meaning, is it noise coming from the differential pair, or is it coming common mode across all pairs? CF.
Terry, do you have an answer to that?
It's a double.
I'm sorry, other station. Go ahead.
SB, I have some information there.
Yeah, go ahead.
My other concern is noise on HF frequencies that are generated by the power supplies that power the switches and hubs and everything else that are on these Ethernet cables. That signal is a common mode. And in fact, I think using a shielded cable might in fact increase the problem, because the shield itself acts as the antenna, and it broadcasts the noise that's generated by the wall wart that powers the unit, the switching unit, the Ethernet switch. This VHF signals, I have put chokes on each end of the Ethernet cable, and that does reduce the HF common mode signal, but does nothing for the VHF signal. So I believe that this is in fact a direct radiation from the twisted pair differential mode. W0ASP back to net.
So, and there's also shielded RJ45 jacks, and those should be grounded. So on a shielded twisted pair, the jacks themselves should be metal, and the plugs themselves should be metal. So everything is supposed to be grounded when you shield everything, so that shield is to ground. I don't know if that would make a big difference with the shielding and its effect, but it is supposed to be grounded. Ben, did you want to add anything with the differential interference?
I guess I was curious, because if it was differential, this should be the scary portion in terms of being able to pick up the contents of the data that's being sent over to Ether. If it's really the common mode noise, then yeah, it could be like anything signaled over ground or something like that. That's not data that can be picked up. Also, another thing I forgot to mention is I thought Ethernet's like Gigabit Ethernet. The voltage, I don't know what the impedance of the wire is, but the voltage across the wires, although, I mean, it is differential, but it's only like a couple volts, maybe 1 or 2 volts maybe. So the signal is not very strong. So, I don't know, just curious, what kind of things people have found about these signals.
Yeah, it's definitely an interesting thought to wonder if you could actually get the bits from that. Anybody else want to add anything on Ethernet radiation, or any other electromagnetic interference, or any other topics they'd like to discuss? Please call.
CK?
Yeah, go ahead, Mike.
Yeah, this is KE0LCK. Originally, we started out talking about EMP from atomic blast, yada, yada, yada. I'll put my tin hat on, made out of aluminum foil, which is certified safe. Anyhow, there are tons of things on YouTube, one of which is a fellow that does a series of these regarding EMP, and it's called Disaster Prepper. Anyhow, he does some testing with some electromagnetic signaling with different types of barriers that he shows work or don't work depending. But one of the things that I found very interesting, that a lot of the testing he does in a room very similar to the space up at WWV, where it was a Faraday cage where you have a door that you can close and it locks a certain way and has seals around it. Anyhow, I found that interesting, but some of his methodology seems reasonable. He offers some solutions for that, but I think it's much more likely to have other interference occurring, and with cabling being able to ferret out and eliminate some interference. Back to that.
Yeah, definitely if you're going to be doing testing like that, you definitely want to be inside of a Faraday cage and eliminate all outside signals. That's for sure. We do have a question from YouTube. It was wondering what software is being used to capture the radio traffic and broadcast it to YouTube. The software it's actually a soundboard, a Yamaha soundboard that acts as a sound card. And then I am using Adobe Audition to capture that to YouTube. Anybody else want to add about the electromagnetic interference or any other topics? Please call.
Is your CF about EMP testing?
Yeah, go ahead, Ben.
Well, I don't think we can set off nuclear bombs to test our radios and all other electronic equipment, but one thing is lightning strikes. Although I'm not going to talk about lightning striking antenna, but having a lightning strike near antenna, not actually, let's say you're in a Faraday cage and lightning strikes outside of the Faraday cage. Ideally, you should not get a pulse inside of the cage, and maybe that's something that someone can do to see how well they're prepared to stand some of these types of electrical behavior or issues, or what you want to call these things, not noise, but perhaps damage that could affect your radios. AE0CF.
Yeah, thanks, Ben. Any other comments on electromagnetic interference? Please call.
W0ASP with a slight shift in topic, if I might.
Absolutely, Terry. We're doing open topic tonight. Go ahead.
Rather than go into all the catastrophic issues of electromagnetic pulses, something more practical for your typical ham operator, and particularly if you're do-it-yourself, is electrostatic discharge, ESD. And a topic has come up in my mind lately about flooring or different environments of your shack that would either enhance electrostatic discharge or dissipate them. And I'm wondering if anybody has any experience in ways to reduce electrostatic discharge.
N0EMP.
Production floor, and they kept the static electricity down by using a electrostatic discharge mat on the work areas, and also that was grounded through. It was always dissipating, and that's what I know about it. So anyway, we're back to net.
And we had Greg in there, N0EMP. Go ahead.
Yeah, I'm sure everybody is well aware that we get very dry air here in Colorado and really good carpet shocks. I saw somebody destroy an Arduino once while he was demonstrating it to me by touching it, and a big fat spark jumped out to it. One of the repeater buildings that we have some stuff in, it's a modular building at the South Tower on Horsetooth. It's where RM Ham has their stuff. It has a floor inside that looks like a linoleum floor, a white linoleum floor, but there are warning signs saying not to wax the floor because it's conductive, and the wax would interfere with that. So apparently you can get conductive flooring material. I know there are conductive rubber materials. I don't know how expensive that is if you get it in sheet form. Obviously, I would say stay away from carpet, and unfinished wood is a reasonably good static drain because it holds a little moisture and is a little bit conductive. Then, of course, you have, you can go with a metal table and metal shelves and everything else and bond everything together. So there's some options out there, but obviously staying away from certain fabrics and carpets and certain types of shoe material will go a long way. And 0EMP.
NW0U.
Yeah, go ahead.
Full manufacturing facility treatment includes all of that, plus adding humidity to the air. High humidity, as in curls my hair kind of high humidity. The special tiles have a special little downside to them. They're conductive based on metal particles in the tiles, but with wear, the metal particles get out and then they get sucked up by the fans and blown into the servers in the server room. So for every measure, there's a countermeasure and a negative response. The manufacturing environment, we had anti-static cloaks to wear. We had conductive finger cots to handle the ICs with. We had little bitty ion generators at the workstations. We had anti-static mats. And the whole business is, if you want to go with 100% route, it actually is pretty complex.
Did that answer everything, Terry, or do you have more questions about that? I'm sorry, I doubled with somebody. Please come again.
Sorry, Dave, that was me, W20ASB. I was saying that I didn't get his call sign. The previous caller was dealing with sounds like a very, very extreme environment, but obviously our hams, we can't replicate that kind of thing. I mean, what's more reasonable?
You can't go the full boat manufacturing environment, but conductive matting over your carpeting, not wearing wool while you're working, rolling your sleeves way up so you have skin conductivity, higher humidity, ground strap between you and the work surface. That's probably about as much as you can do in a reasonable sense, but you have to be aware that when you leave your work area and come back, you should ground yourself before you resume work.
Yeah, discharge that static before you go and touch anything that is not got a shielding around it is definitely good policy. Any other comments on that, please call.
Dave, I doubled W0ASP.
Be an insulator because it's plastic, and if it's been waxed, it's even worse.
Oh, he had a bit of doubling there. Terry, go ahead.
I got a response to my vinyl tile question, but I didn't hear it.
W0U with vinyl.
Yeah, go ahead, NW0U.
Again, vinyl being a plastic, it's an insulator, and if it's waxed, it's even more of an insulator, therefore it would hold a static charge. It doesn't necessarily generate it if you rub against it, but it would hold a charge.
Got that. W0SB back to net.
And 0 EMP.
Go ahead, Greg.
Yeah, in some situations you don't want a really conductive surface because if you are charged and you touch it, you get a high current flow, which is bad. That's why a lot of the ground straps have like a 1 to 10 megohm resistor in them. But a inexpensive work surface, if you're going to be sitting down and working on perhaps a circuit board, doing some repair or building one or something, and you have ESD sensitive components, is again a unfinished wooden surface that you can work on, maybe an unfinished wooden table. And before you put your stuff on the table, spray it down with a spray bottle of water to get some moisture into the surface, and then have your grounded strap for your body, and so that you're at earth potential, and the wood table with some moisture in the surface might be good for 30 minutes to an hour. Would be conductive, but still resistive, so it's not a really good conductor, but it will still drain away charge. And 0 EMP.
0 WIQ with a comment.
Go ahead, Carrie.
The static discharge in electrical components. It didn't really show up as much of an area until we got integrated circuits where the components were real small, so it didn't take much to zap them. And so it still is a matter of getting what you're working on and yourself at the same potential to work on this stuff. And big prevention stuff in a manufacturing situation was so that you could get up and walk around, do other things, then come back to your workstation, and everything on the workstation and you are about the same potential. But it is actually the potential difference for the static charge to discharge across that makes the difference. So I just thought I'd mention that.
Yeah, having a good method to drain away static before you start working on unshielded components is definitely helpful. It's definitely something everybody should be aware of for sure. Any other questions, comments, or topics they'd like to discuss with the net, please call. Well, hearing none, we've definitely had a pretty interesting open discussion today. Any other questions or anything else before we close the net, please call.
WIQ with a comment.
Go ahead, Carrie.
Time you have current, you have a magnetic field around it. So, I mean, the twisted pairs cause odd-mode rejection of each other, so we go that route too. But current, no matter how it's generated, has an electromagnetic field around it. And so, you use a spinning or you spinning wire close to a magnet to make current. And the AC current is basically an electric motor, a multi-phase electric motor, spinning backwards so that it'll generate current if you activate the field around it. And all that kind of stuff. So current and magnetism are hand in hand. You can't have one without the other, period. Back to net.
Yes, that is definitely true, for sure. Any other comments or topics before we close the net? Please call.
V0ASB.
Go ahead, Terry.
Confirm that carpet is a very, very bad surface to be working on your electronics, because back around in November I was working on the radio telescope at LTO and replacing a integrated circuit. Actually, it was a mini circuits box, and just from the static of the carpet and on my shirt, you have to lie on the floor to get to the receiver there. I zapped the thing, and that was a real pain. It causes a whole lot of trouble. So definitely carpet is not a good surface for flooring if you're dealing with electronics.
W0U.
NW0U, go ahead.
That's for carpeting is static guard, like you use in your laundry room to basically make your clothing conductive so that synthetics don't stick to each other. So a temporary fix to working in your area would be to spray down your carpeting with a static guard.
No, that's definitely an interesting point. Yeah, I definitely try avoiding carpet if I'm ever working on circuits. I generally go out into my garage workbench to do that sort of stuff. Yeah, that's just my process for sure. But I never thought about the static guard for sure. Go ahead, Terry. And just a FYI, you got significantly quieter on your last transmission. I don't know if your mic gain got turned down or what's going on.
U0ASB, how's this?
You're still pretty quiet.
Technical difficulties. I wanted to ask N0WU, how long is that static guard useful?
not know the answer to that, NW0U.
Zero CF comment.
Go ahead, Ben.
Well, just wanted to make sure that how people, when they're handling static sensitive devices, are you, I guess, keeping all your static sensitive devices in their container and carrying the container that's static shielding up until the point where you're ready to install or something like that, just so that you can go and discharge whatever static at the point where you're working, and don't carry these static sensitive devices around when you're working on them. At least that's what I've been trying to do in my house, even with static. I definitely have a big static problem, and after I damaged a whole bunch of devices, I try to keep them in a static safe container when they're being carried, and when I'm just about ready to start working on something, discharge myself far away from the device, and hopefully that will mitigate a lot of the damage I could incur from discharge. AE0CF.
And to expand on Ben's topic, or Ben's comments, the static bags and keeping them in a statically shielded bag, all bags are not created equally. I've actually seen static go through the static bags that have the printed stuff on them, but I have not seen it go through the stuff that has the like metal layers in it that you can kind of see through, but it's like silvery. So I generally much prefer the silvery static bags, and try to use those and try not to use the printed ones at all. Any further comments for the net, please call.
N0PQ.
Yeah, go ahead.
Yeah, N0PQ. Was that for me, or did I double with somebody?
Nope, that was for you, N0BQ.
Okay, thanks. Just one comment. I work in the semiconductor biz, and one thing people may not be aware of about ESD is latent damage. So ESD doesn't always destroy semiconductors. Quite often it pops little holes in the gate oxides, which is an insulating layer inside the semiconductor. And what can happen is it causes latent damage. So maybe the part works fine, and maybe 6 months from now it fails. So you should be aware that just because the part works doesn't mean you haven't damaged it with ESD. So that's one reason you need to be careful. N0PQ.
Yeah, those circuits are definitely super small and very sensitive to things like that, the electrostatic discharge. So damage can be done that just reduces the lifespan of the component, and that's also not desirable by any measure. Thanks for that. Any other comments for the net, please call.
Comment from N0WIQ.
Go ahead, Carrie.
Manufacturing facilities of HP took static and latent damage seriously, because latent damage means that it could fail just any time. And HP was building equipment with about a 1-year warranty. And so sometimes the latent damage would be done so that the warranty would have to be covered in the process. So that's where they got sensitive about static in that manufacturing process. Anyway, that's my comment. If something's under warranty, it will be replaced in most cases. But if it's a statically caused latent damage, it might be somewhat of an argument because most people don't think about protecting things from static. My comment.
Yeah, it is nice when you can get something repaired under warranty. However, a lot of times it's still a big problem, and whatever machine being down during the course of time that you're getting the replacement is definitely undesirable. So it's definitely good to have good practice when you're working with unshielded components, and make sure that static is a consideration, and you ground yourself and discharge any static that you have, and make sure to do that before you go and touch those electronic components for sure. Any other comments for the net? Please call.
Zero ASP, is my signal back to normal?
It is, Terry. Beautiful signal now.
These TYT and their mic connections. I do have a bit of a anecdote about static. I recently bought some amplifiers from a manufacturer in China, and they did not send them in static-friendly packaging, and there was about a 50% failure rate on the components.
Yeah, it's definitely amazing how easy it is for a little bit of static to take out a lot of stuff. Any other questions or comments for the net, please call. Hearing none, this is Whiskey Zero Delta Delta Zulu for the Northern Colorado Amateur Radio Club TechNet. Sorry again, not being as prepared as I usually like to be for the nets, but it was still a great conversation. I definitely love having these chats and just being able to just discuss whatever's on everybody's minds for the night. It's always interesting. We will do this net again next week, Monday at 6 p.m. Also the Club Net is coming up on Wednesday, 6:30 p.m. for the regular net. Early check-ins start at 6 p.m., so hopefully you guys can join us there. Anything else for the net before we close up for the evening, please call. Well, thank you everybody for participating, and remember, if you guys do miss a net, we do stream them up to the YouTube channel, and they are also recorded up there, so you can catch up on previous nets. And we look forward to seeing you guys next week. This is Whiskey Zero Delta Delta Zulu, closing the net this evening, and the repeater is open for general use. Thank you guys, and good evening. Thank you for watching, and don't forget to like and subscribe.